Reverse phase chromatography, separation of biogenic amine neurotransmitters and its derivative using reverse phase chromatography. Structures of compounds that being eluted from this chromatograph. Firstly is homovanillic acid (OHVA), second 3,4-dihydroxymandelic acid (DOMA), 5-hydroxyindoacetic acid 5-HIAA, serotonin, dopamine, 3,4-dihydroxyphenyl glycol, 3-methoxy-4-hydroxyphenyl glycol, vanillin acid, 3,4-dihydroxyphenyl acetic, and also 3-methoxytyramine. From chromatograph shown at the screen, there were about 10 compounds of biogenic amine neurotransmitters and its derivative, which being separated using reverse phase chromatograph. Reverse phase chromatography are different from normal phase chromatography, where the stationary phase is hydrophobic and the mobile phase is a more polar aqueous solution. Hydrophobic interaction is the main separation mechanism in reverse phase chromatography, where the more polar analytes will be eluted earlier, while the non-polar analytes are therefore retained strongly to the mobile phase. Van der Waals forces are the main forces to occur in this mechanism. Although these forces are relatively a weak force, a high number of molecules as well as increase in molecular size will contribute to increase the interaction between the analyte and the phases. Therefore, strong forces may be produced within these factors. The first compound to be eluted is the 3,4-dihydroxymandelic acid or DOMA. This is because this compound had the highest polarity against other compounds, since there are about 3 hydroxyl groups attached to this compound as well as the carboxyl group, which make this compound to be more polar. Many hydrogen bonds can be formed from these functional groups, and this causes DOMA to have strong interaction to the mobile phase, which is methanol. Therefore, DOMA is eluted first. Vanillyl mandelic acid or VMA is the second compound to be eluted. This compound has almost similar structure as DOMA, where they had the same functional groups, which are carboxyl group and hydroxyl group. But the presence of ether group in VMA, which is less polar than hydroxyl group, causes it to reduce the polarity of this compound and results in returning weakly to the mobile phase. Next is 3,4-dihydroxyphenyl glycol or DHPG. Not like those first two compounds, this compound only has hydroxyl group attached to, but it has the most number of hydroxyl group compared to other compound after it. Dopamine or DA is eluted first than 3,4-dihydroxyphenyl acetic acid, DOPAC, even though DA has amine group which less polarity than carboxyl group present in DOPAC. Serotonin or 5-HT has higher retention time than 3-methoxy-4-hydroxyphenyl glycol or MHPG, even though both has almost similar structure. Serotonin has amine group attached to it, which causes this compound to be less polar than MHPG. Therefore, less interaction occur with the mobile phase, cause it to have longer retention time. Both 5-hydroxyindoleacetic acid or 5-HIAA and 3-methoxytyramine 3-MT have an indole in their structure, but presence of carboxyl group in 5-HIAA should make them has less retention time than 3-MT. Homovanillic acid or HVA has the longest retention time in this chromatograph, despite having a carboxyl group as well as hydroxyl and ether group in its structure. These results may be affected by the stability of the amino compounds, which influenced by certain factors like pH and concentration of the mobile phase, which is methanol. Presence of light and air were very crucial to the stability of indoles, and that may explain why the compound seems to have different polarity.